Break is over. Welcome back, everybody. So these three cornerstones, sequence, selection, and iteration, allow you to learn any kind of iterative programming language. If you know the data types and how to control the flow of execution, then you're already in a good position to be able to start writing code in that particular programming language. So in the future, if you find out that I don't know, maybe not Python, Anaconda, Cobra is the next programming language that everybody wants to use, then, and it's an imperative programming language, then I suggest you go through and figure out how to do sequences, selections, and iteration in order to become proficient in that language in short notice. Now, the next step that you need to master for any programming language that you may want to learn is if there are any advanced data types. Now, usually those are compound data types, arrays in C, structures in C, classes in C++, and containers in C++, vectors, hash maps, things like that. Python does not have by default any built-in array data structures, but they do have lists, and lists are very powerful. They allow you to use, or you can use lists in order to mimic or get the same effect as you would from structures in C and C++, as well as arrays. Because in spite of their names, they're not actually implemented as the kind of linked list that you may expect if you just finished your first year programming course. They actually are array lists, which are a much more efficient implementation for that as the standard linked list approach. So we can have a list. It's indicated by a square bracket. So that opens a list or starts a list. And then here I have a number of entries separated by commas. So I have a list which has a 1, a 2, a 3, a 4, a 5, a 6 in it. Now I can also put a 4.5 there. So because Python is dynamic, that means not every element in the list must be of the same type. In C, I have int a 7, then I get 7 integers, but nothing else I can put in there, no floating point numbers. Similarly in C++, where the vectors are typed, then I can put in a string, Joe and Bob and Bill, and I can even put in another list into my list. So this particular element here is one entry in the list, but it's in itself a list which includes A, 10, B, 20, C, and 30. Let me just change that. So that it looks nicer. Now, to get an element out of the list, first element is indexed as 0. So that's the same syntax that we use in C to access an array. So list 0 will return 1. And the length of the list gives me the number of entries in the list. In this case, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then this entire list is entry 11, 12, 13. So I have 13 elements in my list. Python also came up with a clever idea of overloading the index operation. So if I access list of -1 in C or C++, that would actually give me a silent error. In Java, it would give me an array index out of bound exception. In Python, this actually makes sense. List -1 is the last element of the list, so this will return 9. So it's the same as the length of the list -1. These two statements are actually equivalent in Python. So list -2 will give me the second to last element. That will be the 8. And I can also use slicing. So slicing is extremely powerful. I can extract a sublist from a list very easily. The start index is included, the end index is not included. So here I have 0, 1, 2, 3. So the first element is a 4, and then 5, 4. The first element is a 4. Then I get the 5, and then I get the 6, and then the 4.5 is at index 6, so it's not included. The index of this here is 0, 1, 2, 3, 4, 5, 6, so it's not included. I can also do lists from the end, so I can go -4, so the -1, -2, -3, -4, so it's from Bill all the way but not to including the 9. So it will give me Bill, then that list, and 8 as output. So this is the output here. So you have some powerful operations on lists for indexing them, as well as appending them, of course, together, appending an element or extending a list in Python. The other advanced data structure that is often used are dictionaries. Dictionaries are like hash tables. You have a key. The key can be anything. In this case, it's a string saying Joe, and I can say Joe owes me $20, Bob, I owe Bob $5, Mary owes me $3 and 4 euros, and in ID 234, which is now an integer, has some other value, dummy, has a dummy value. So to access these elements, then we use square brackets, but now with the value of the key, either the string Joe or 234. Again, these data structures, lists and dictionaries, are the most commonly used data structures in Python programs. We also have tuples. Tuples are the same as lists in basically all aspects, except in contrast to lists, they're immutable. So here I have a list, square bracket, right? 1, 2, 3. So I have a list with 3 entries, integer 1, 2, and 3. Then if I want to, I can overwrite the 1 here, index 0, with 5. Now my list has 5, 2, 3. If I have a tuple which is indicated by round brackets, then I can also define it 1, 2, 3. But then if I try and overwrite index 0, then I will get an error saying that I'm not allowed to change the entries in the tuple. Let me just catch the correct access exception. So here this fails. I also have sets. Sets are like dictionaries, but with only keys, and every entry in a dictionary, the key can only occur once. So that gives us a data structure where every element can only occur one time. So here I have 1, 3, 4, 5, 2, 2, 2, 2. And since it's a set, I only have 1, 2, 3, 4, 5. The multiple 2's here are all combined into one. That's sometimes useful for some applications. Iterating through loops. Again, we can iterate over a list by saying that for E in list, that gives us every element. Tom, Mike, Judy, and Martha. So this will print out Tom, Mike, Judy, and Martha. Similarly to the following C++ code. Or ranged loops for I in range 5. And if you, for formatted output, if you may have noticed, every time I used the print statement so far, it would start a new line. If you don't want the new line at the end of your print statement, if you want to continue on the same line, then you need to overwrite the end parameter. So here I can say after the print statement, I want you to end with nothing, which means that now I can do multiple prints on the same row. Now, it's important to look at the difference between those loops. Another common idiom would be this version, where I say I get the index, the position of the element. So if I only care about the element, then I can just do this, right? For E in the list, and I don't need to worry about anything else. If I need to know the position and the entry, then I need to iterate over I as the index variable, and then I have access to the position as well as the actual value via the index access operator. So then I get this output: 0 Tom, 1 Mike, 2 Judy, 3 Martha. Either one of those two are usually what you do in order to deal with any kind of list input into your program. There's also enumerate as a shorthand for this version. I don't think it actually does so much. Doesn't provide a huge advantage. Basically, it saves you typing one line. Here I get the same effect if I type it like this. Right, so not really a huge improvement. So if you forget about enumerate, then you will still be able to write good programs in Python. Then we can do a while loop, index iterating over the list until some condition is false. So here I'm checking if the previous element is less than the current element, and then I print it out as previous. Go to the next one. So 4 is less than 5, 5 is less than 6, 6 is less than 7, 7 is less than 12, but 12 is larger than 3, so that's when the loop is going to terminate. Here's a slightly more or actually just a general form of the if statement. If x is less than 20, they're young. If they're less than 30, then they're middle-aged, and otherwise, if the, I don't know, the neck size is 20, then they should be young. Otherwise, they're middle size. Otherwise, large size. Now, I said Python also supports object-oriented programming, and before we go to there, another thing that is one of the important aspects of imperative programming, any kind of programming language, is how you want to structure your program. In Python, that is done by defining functions. Everything by default is a function. If you don't return anything, then the Python interpreter is going to return none for you, which is the null pointer in Python. It indicates a non-existing element. So to define a function, we use the def keyword, and then I can say def define a function power, which takes two numbers as inputs, two values as input, x and n, and then I return x to the power of n. Now again, as you see here, there's no types associated with the arguments. Python is a programming language that uses duck typing, which means that instead of specifying what kind of arguments you are willing to accept, you simply accept anything, and then if it runs through your code without generating an exception, it was the correct type. And if not, then it was not the correct type, and you have to do something, catch the exception, whatever you need to do in order to keep your program running. We also have object-oriented programming paradigms. So I have a class animal which has a constructor. The constructor in Python is called init. The other thing that's different from between C++ and Python is that the this pointer that you get in C++ is called self in Python, and it must be mentioned explicitly. In C++, if you define a member function, then it would be int length, and then not length, let's say int increment, and then the value of the increment. Then you can do something like this dot value is equal to this dot value plus increment. The this you don't need to actually specify in your function. In Python, I need to put it there. So in this case here, I need to say that I have a this pointer coming in, and then I can use that in order to access my instance variables. So here I have a constructor which takes a name and a hello. So the name is name and the hello is the hello string. And then if I have another member function that uses speak, and then it says self.name plus says plus safe.hello. So fish is a subclass of animal. So fish will say blurb by default. So I could have another function here, speak, saying that it will automatically say blurb. So I can say that I can create a dog which will say woof woof, and I can create a cat which will say meow, and I can create a fish which just is the name of the fish, carp. Huh? Yeah. and then I can call speak on them, and then as you would expect, you get to hear woof woof from the dog and meow from the cat and blurb from the carp. So you get dog says woof woof woof, dog says woof woof, cat says meow, carp says blurb. That's one fairly sort of standard way of doing object-oriented programming. Apart from the explicit self pointer and the different name for the constructor, the inheritance, things like that works pretty much the same way that you would expect it from if you're coming from languages like C++ and Java. It does support multiple inheritance, so it doesn't use interfaces the same way that Java would. Also, you may have realized, or you may have seen here, Python is clearly targeted as a prototyping language. So the idea is to get a running program fast, running working program fast. So here, in contrast to C++ or Java, there's no protection. So there's no private instance variables. There's no protected class, things like that. In Python, but everything is public. So if you know that your object includes instance variable called name, then you can always access them. There is a convention that if it is a double underscore, then it should be considered private, but that is not enforced. That is really just the way that the programmers say that I'd rather not you touch this variable, but nobody will actually be able to stop you from it. The idea for Python, our best description for Python programming language, is that it's basically pseudocode that you can execute. So it doesn't provide a fine-grained ability to restrict access to certain variables and things like that. If you need that, then you should probably reconsider implementing things in a statically typed programming language anyway, because then you can guarantee that all the data that you get, that you have as input, will actually confirm. So if you expect a string here, then you can specify that this must be a string, otherwise your program won't even compile. Now, since it's interpreted, Python also allows you to do metaprogramming in Python itself, which is pretty neat. So we can take a string and exec it or evaluate it, and then we will actually get the corresponding program compiled and ready to be executed by our runtime. So for example, here I have a string for an expression. That expression in itself is a legal Python program, right? It says y is equal to 5. The result is x plus 5 times y. Then I define a function clear, which takes a list and an end element, then goes through the list, and if that list is equal to x, then I set it to 0. Then I have a list, then I call clear on that list, and then I print out the list. Now, what I can do is, if I now just put that code in, then every time I need to call clear, it will, anytime I need to make sure I need to remove a certain element, then I need to call this clear function here. But let's say I know, one thing I know is that if the value that I want to clear is bigger than the maximum of the value that's in my list, then I don't actually need to do that. Or if I have some other knowledge that says sometimes I don't need to call this clear entry here, then what I can do is I can take that that element here, that expression here, and replace it so that in the string, this clear list X, this line here, will simply be removed. Now my program is going to run a lot faster, right? Because it doesn't need to go and check the list to see if it needs to remove any elements or not. So I can write the program that I want to execute at some point later, and I can manipulate it using string manipulation functions. So now I have this. If the entry is bigger than the list, then when I execute this code, this function here will never be called. If I call it with 10, because 10 is larger than any element that I have in the list. So this is a very powerful feature of Python. The idea that we can change the running program as we're executing things and rewrite it is a very powerful ability. Now, a lot of simple loops like this here, loops over lists, they occur very often. And I said before that Python does support some functional programming paradigms. One of them is list comprehension. Which allows me to write that loop as basically a construction of a loop where I say x times 2 plus 1 for every x in the range from 10. So that will be 0 to 9. So x will go from 0 to 9, and then I'll get 0 times 2 plus 1, 1 times 2 plus 1. So I will get all the odd numbers up to, but not including 20. So I get 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. I can also attach tests to this list comprehension. So here I can say x to the power of 3 for x in the list if x is less than 11. So here I have 1, 3, 5, 7, 9, 11. So I will get 1, 3, 5, 7, 9 to the power of 3. 1 to the power of 3 is 1, 3 to the power of 3 is 27, 5 to the power of 3 is 125, 7 is 343, 9 is 729. So these kind of list comprehension, of course, you could write it as a for loop, but then it will be, your code will be longer. It's and also run slower. These list comprehensions allow you to construct lists and filter lists very quickly. And then lastly, we have formatted output. There's a format function which now is actually replaced in Python with format strings. So instead of having to have a string and then dot format and then what I want to call the element, so here I say I want to print out x. X is a floating point number that I want to print out with 5 decimal places and 8 after the decimal point. And here y is a number, a decimal, that I want to print out with a field width of 10, and k is just printed out as a string. then I can generate these formatted output, so I can print things out the way that I to make them look nice, basically. Now, also one very clever feature of Python that I like a lot is that the help is built in. So anything that you have in your program, you can usually find out very quickly about its type, the operations that are available. So if you don't know about lists, you can say help lists, and it'll give you all the different values that or give you a help message for that particular module or object or type. You can also define your old help as a string following the declaration of your function. So here I define a function that takes two arguments, a and b, and I just put in a string saying this is a simple test function that does something with a and b. Then I can type help function and it will return this string to me. So it's sort of dynamic runtime Java doc. And there's the output. And now let's have a look at our very first program, FizzBuzz. FizzBuzz is famous. You may have heard of the problem before because it was used by Google as a very early test for interviews. If you wanted to get a job at Google, that's one of the first questions they would ask you, if you can solve it. And the problem statement is quite simple. You're supposed to write a program that will print out, that will start counting from 1 up to 100. And so it's actually a children's game from Australia. So children will start counting 1, 2. If it's a number that's a multiple of 3, then you have to replace it with fizz. So it would go 1, 2, fizz, 4. If it's a multiple of 5, it has to be replaced by buzz. So it will be 1, 2, fizz, 4, buzz, fizz, because 6 is 2 times 3, so it's a multiple of 3. 7, 8, fizz, buzz, 11, fizz, 13, 14. And if it's a multiple of 15, then you have to print fizz buzz. And the question is simple. Write a program that will print out the correct fizz buzz statements. And as you can see, this is one way to do it in Python. If I modulo 3 is equal to 0 and I modulo 5 is equal to 0, which means it's divisible by 3, divisible by 5, then print fizzbuzz. If it's a multiple of 5, print buzz. If it's a multiple of 3, print fizz. And otherwise, print the number itself. And then I can run that. And I get 1, 2, fizz, 4, buzz, fizz, 7, 8, fizz, buzz, 11, fizz, 13, 14, fizz, buzz. And then, of course, I can run it larger numbers. I guess the reason why Google uses it as a screener question in their interviews is because if I try it with most people, when they code it up, initially it would be something like this. So if it's multiple of buzz, multiple of 5, print buzz, multiple of 3, print fizz, multiple of 15, print fizz buzz, and then print the number itself. This code is incorrect because if you run it, then you can see it here for 15 it'll print buzz rather than fizz buzz. The reason being that if it's a multiple of 5, it will never check this line, right? This will be true. It'll print buzz. It'll never execute this part of the program. Another error is this version here, where then people try to be clever and say, oh, if it's a multiple of 5, I print buzz. Multiple of 3, I print fizz. But if it's a multiple of 15, it'll actually print buzz and then fizz buzz. So that's also incorrect. So here's another program. Return the maximum odd number in a list. That would be here. We set M initially to be our none element, like a null pointer. Then we check every element in the list. If it's an odd number, so the element modulo 2 is equal to 1, then if M is equal to none, so I don't have a maximum yet, or the current value is greater than the maximum, then I remember what the maximum is. At the end, I return the maximum. And then 139.2.12.5 will return 9, -1. So that's why I cannot just say M is equal to 0. Some people want to write M is equal to 0 here. That would be a problem if all the odd numbers are negative, right? Because then I get -1, -3, -9, -5. The maximum is not -0, but it's -1. And if it's 2 and 12, I have no odd numbers at all, so there is no maximum. So in this case, I would return none. And this is all working correctly there. So now for you guys, try and implement this function, maximum number after odd. So you return the largest number that follows immediately an odd number in the list. So if I pass in a list with 1, 4, 2, 7, -1, 5, 7, no, 3, 5, 3, 2, then that should return. The odd numbers are 1, 7, 5. The numbers following the 1, we have a 4. Following the 7, we have a -1. Following the 5, we have a 3. Following the 3, we have a 2. So the maximum number following an odd number should be the 3. So I'll give you 10 minutes, implement that particular program, and then send me your solution via instant messenger, via direct message. So open up your idle program editor or Visual Code. If you installed that, you can also use that to write programs in Python, or any other iterator for that matter. And then try it for yourself. The solution is actually at the bottom there, but don't look at the solution until you have at least tried it for a while. While you're doing this, I can show you some of the program that I've been working on in Python recently. You may be interested in that. So the roll call, all of that happening. Coming out this one. This is some Python program that I wrote. If you're interested to see what a more complicated Python program looks like, this is actually the bot that does roll calls and enrollment and everything. So you can see if you type links, then this is the program that will actually be executed. So I get the message author and direct message channel to the author, and then I check which permissions. The roles are basically the permissions on Discord, and I convert the role into the name of a channel that I can use. And then I go through, get the courses, check if the title is all or if it's a course that matches the particular role. If that's true and there's a set of links, then I will get the links and append them to my output. And then I generate a list which says this is the title of the link, this is the URL, and then I send it to the user. And there's a roll call command as well, and here's the enroll command, which enrolls students in the database. So I will want to add some more commands later. Also another part that Python is very strong in is scraping of websites. I can get the HTML from a particular website, and then I can go through and check what the announcements are, and then print out the X number of announcements. So in order to get the announcement, it has to have a tag of a list item, it has to follow an ordered list or an unordered list, and then has to be inside of the list, and it has to include announcement or notice in the text somehow. So that way I can print out the latest announcements from websites automatically on the Discord bot. So you can see Python code in general looks very clean. Not many, there's no curly brackets or semicolons. So it really reads very much like pseudocode. Okay, so let's see how you guys are doing. If you have been able to solve my little programming problem. So you have 1 more minute. These little exercises, if you can solve them, you can get some extra marks in the course. So make sure you submit them. So you have 2 minutes left. So send me your code via direct message to NKUST. And the problem is this one here. Maximum number that follows immediately after an odd number. So here, submit your solution for extra points. So right, time is up. So now, as I said before, two ways to iterate over lists, right? Either for each element in the list, that's the easiest way. That gives me each one of the elements. For I in range, length of the list will give me the index, the position, as well as the element. So then I can figure out which one is the next element or the previous element. So that particular problem, here would be the solution. The current maximum is none. Then I go through the list. Now I always have to look for two entries, right? The current entry and the next entry, the next number, because I need to check if the next number is larger or not than the current maximum. So that's why I only iterate through to the length of the list minus 1. Then I check, I get the element at position I. If that is an even number, if that's an odd number, so E modulo 2 is equal to 1, then I get the next number entry. If I don't have a maximum yet, or the number is greater than the maximum, then I remember that as the maximum. And then here I just generate some random numbers and I print out the output of my program, so you can see it's correct. -2, the 7 doesn't follow a even number, so it's not the maximum. The -7 follows the 7, so that will count. -7 is odd, so the 5 counts. 5 is odd, so minus 6 counts. Minus 6 is even, so the 10 doesn't count. 10 is even, so the 1 doesn't count. 1, nothing follows after it anymore. Minus 4, minus 9, minus 10, minus 2, 3, 5, and 2. The odd number 3 follows the 5. So the 5 is the maximum there, so on and so forth. So that will be the solution that I asked you to write right now. You should have just written a 5-line program. So practice your Python programming some more so that you can do these kind of problems very quickly and efficiently. You can see why I need to put a minus 1 here, because if I go to the end of the list, then now I plus 1 is going to be 1 past the end of the list. So if I run it, I get an error. Index out of bounds exception, or an index error it's called in Python, saying that I'm accessing an element which is not part of the list. Same thing as array out of bound exception in Python. Oh. So then you can play around with this code a little bit. So here's the error. Now here, the error is a little bit more subtle. It's actually harder to detect. And the reason for that is because if I execute this statement, then if I is 0, then the index is going to be minus 1. Minus 1 is actually a valid index. It's going to be the end of the list. So if I have a list that is 10, 3, 6, 5, 7, 8, 9, then the correct output should be the 10, the 3 follows the 10, so 10 doesn't count. 3 is odd, so 6 would count. So we have 6, 5, 6 is even, so 5 doesn't count. 5 is odd, 7, so we have 7. 7 is odd, so we get 8. 8 is even, so the 9 doesn't count. But my program will actually output 10 for this problem. And you have to be careful with the indexing here. So list minus 1 is the last element. In this case, the end of the list actually has a 9, which is odd. So we considered this to be a valid candidate for the maximum. So it'll allow 10. And then 10 is larger than any of the other ones. So this will give you an error that's not actually that easy to track down. That's why when I write a program, I try to avoid doing index minus something, because if that overflows, then you end up with a negative number, but negative numbers are actually allowed, right? So you will often get behavior that you didn't want, that you didn't expect. So I think it's better to do plus if you need to do offsets to indices, because then if it's too large, you will automatically, there's no wraparound, you will get an array out of bound exception. Oops, I have to switch to my Chrome. So this is the program here. As you can see, if we run it, now I get an error here because it'll return 10 in spite of because the 9 is at index -1, it's the last element. So if I is 0, then list of -1 is 9. 9 is odd, so the current value 10 is a legal value. Considered for the maximum, it's the largest number, so it'll return 10 here, which is incorrect. The correct output should be 8, not 10. And here we have the same thing on another list. So let me So this bug is not so easy to detect. So when you actually run it, then some of them may turn out to be correct, right? Like here, 3, 2, -5 is odd, the maximum is 10. So the output looks like your function is working, but actually it's not. Here's one example where it will fail. So then let me finalize the program. I will need to open my secret window. And then GitHub token. Ui. So now it will update the presentation on here, but it will take about 30 minutes on GitHub server before it'll actually post it. But you can use that notebook and then access the presentation later on. And then next time, try and submit your programs, your exercises. Okay, that's it for today. Tomorrow, class will be from 9 to 12. And if we have some time, I will put in the automatic scheduling bot. If one of your classmates missed the class, then they can watch it on Twitch and on YouTube. I will upload it to YouTube after this class here. Okay, so thank you all for listening, and good night, and I'll see you all again tomorrow. So bye bye.